Welcome! I'm so glad you have found your way here tonight. I invite you to settle in, to let the weight of your day begin to lift, and to join me in the quiet study of the Earth's records. Imagine, if you will, a place of profound stillness, a sanctuary where time does not rush, but rather pools like deep water. This is the Deep Archive, where the great stories of our planet are kept in silent, ancient volumes that require only our patience and our breath to understand. Before we begin our journey into these hidden histories, take a moment to truly arrive in this space. Adjust your blankets until they feel just right. Let your jaw relax. Feel the support of the surface beneath you. If you find comfort in these nightly discoveries and wish to return to this sanctuary, I invite you to join our sleepy community. By subscribing, you gently ensure that we can continue to meet here night after night, exploring the wonders of the natural world in the soft light of curiosity. Your presence here is a gift, and we are so happy to have you with us. As you lie there in the darkness, something wonderful's happening within you. Even as your muscles let go of their tension, your brain is beginning its own nightly ritual. The fast, sharp electrical activity of your waking mind is softening, smoothing out into something more fluid. You're entering a state where your brain begins to produce rhythmic theta waves. These are slow, rolling pulses of energy moving at a frequency that feels like the steady ebb and flow of a calm tide. They are the signature of the transition, the bridge between the world of doing and the world of being. In this theta state, your mind becomes a quiet librarian, sorting through the fragments of your day and gently filing them away into the long-term storage of your memory. It is a comforting thought to realize that even in sleep, we are keepers of our own history. But this process of recording and filing is not unique to us. Just as your mind organizes its internal world, the Earth has spent billions of years maintaining its own external files. It has been a meticulous witness to every change, every breath of wind, and every shift in the tide. Tonight, we will step out from the internal archives of the mind and begin to explore the physical records of the world around us, the natural files that hold the secrets of where we have been and how the world came to be as it is right now. Everything we see around us is a page in a much larger story waiting to be read. As we transition from the quiet rhythms of your own mind, let us look at the world as one vast, interconnected library. A natural archive is not a building made of stone walls and wooden shelves, nor does it contain books made of paper and ink. Instead, it is the earth itself, the soft mud at the bottom of a silent lake, the hidden rings inside the heart of a sturdy oak, or the deep frozen layers of the ancient poles. These are the places where the planet has tucked away its memories, keeping them safe from the erosion of wind and the heat of the sun. In these quiet spaces, time is not a sequence of ticking seconds, but a physical accumulation of matter, layer upon layer, settling into a permanent record of everything that has ever occurred. When we want to know what the air felt like 10,000 years ago, or how much rain fell during a season long before there were humans to measure it, we look for clues left behind in the environment. Scientists have a beautiful and precise name for these indirect records. They call them proxy data. Think of a proxy as a stand-in, a silent witness that speaks on behalf of a time we cannot visit ourselves. Because we do not have a heat machine to travel back and stand in the middle of a prehistoric forest, we rely on these proxies to tell the story for us. A single grain of ancient pollen, a mineral deposit in a cave, or a microscopic bubble of air becomes a reliable testimony. These proxies allow us to reconstruct the past with incredible accuracy, reading the chemical signatures of the earth as if they were lines of poetry written in a language of elements and isotopes. Take a slow, deep breath and imagine the weight of those years. It is a comforting thought that nothing is truly lost. The earth remembers. It keeps a ledger of every volcanic eruption, every shift in the ocean currents, and every change in the temperature of the breeze. This data is not just a collection of numbers, it is a physical history of the world's resilience. It is the story of how life and the planet have danced together in a slow, steady rhythm for eons. As we begin to look closer at these archives, we find ourselves drawn to the most vast and silent of them all. We are traveling now, in our minds, away from the warmth of the modern world and toward the ends of the earth. Imagine the horizon stretching out in a seamless curve of white, where the sky and the ground meet in a soft, hazy blur. We are approaching the great polar ice caps of Antarctica and Greenland. Here, the archive is written in frost and stillness, preserved in a kingdom of ice that has remained undisturbed for millions of years. In this frozen sanctuary, the earth has been breathing in the atmosphere and holding it tight, waiting for us to gently arrive and learn how to read the pages of its oldest, coldest volumes. The silence of the Antarctic interior is unlike anything else on our planet. It is a vast white desert where time seems to hold its breath. Here, the archive is built one snowflake at a time. Imagine a single snowflake, delicate and unique, drifting down through the freezing air. It lands softly on the surface, joining billions of others. In most places, snow eventually melts, returning its water to the soil or the sea. But in the heart of Antarctica, it is far too cold for the snow to ever disappear. Instead, it simply waits, becoming the foundation for the next year's arrival. Year after year, century after century, the snow builds a bridge between the present and the ancient past. As you settle deeper into your pillow, imagine the weight of those layers. As the snow piles higher, the layers at the bottom are slowly compressed. The air between the snowflakes is squeezed into tiny spherical bubbles, no larger than a grain of sand. These bubbles are then sealed shut by the forming ice, creating a perfect airtight seal. This is what scientists call fossil air. It is a sample of the world's breath, preserved exactly as it was hundreds of thousands or even millions of years ago. When a scientist eventually finds one of these bubbles, they are the first living being to interact with that specific pocket of air since the moment it was trapped. It is a beautiful, peaceful thought that the earth has saved its breath for us. These bubbles are like the pages of a book that has been kept in a cold, dark room for eons. By studying them, we can learn about the temperature of the planet, the health of its ancient forests, and even the intensity of the sun in ages long gone. We can see the traces of ancient wildfires and the salt from storms that raged over oceans that no longer look the same. Each layer of ice is a distinct moment in time, stacked neatly and chronologically upon the one that came before it. This process of reading the ice is one of the most quiet and profound ways we have of understanding our home. It requires us to look past the frozen surface and into the deep blue heart of the glaciers. The ice here is not like the ice in a kitchen. It is clear, heavy, and ancient, often glowing with a soft, sapphire light that seems to come from within the earth itself. It is a sanctuary of information, held in a state of perfect stasis. As we stand on this metaphorical plateau of ice, surrounded by the stillness of the poles, we begin to realize that the record is not just a few feet deep, it goes down for miles. To reach the oldest stories, we must find a way to travel through these layers without disturbing the delicate balance of the archive. We must learn the art of looking downward into the depths of the frozen world to see how the earth has exhaled over millions of years. It is a journey into the vertical history of our world where every inch represents a season and every mile represents an epoch. To reach these hidden stories, scientists use a method that is as patient and precise as the ice itself. They use a hollow rotating pipe to gently pull a long, slender cylinder of ice from the depths of the glacier. This is called an ice core. Imagine a translucent straw, miles long, dipped into the very soul of the planet. As the core is lifted to the surface, it brings with it a vertical timeline, a physical manifestation of time that you can touch with your hand. Some of these ice cores are over 2 miles long. If you were to lay one out on the ground, it would stretch further than the eye can see, containing a continuous, unbroken record of the Earth's breath. In the upper sections, the ice is relatively young, perhaps only a few centuries old. But as your eyes travel down the length of the core, you are looking back through the Middle Ages, past the rise of ancient empires, and deep into the heart of the last ice age. At the very bottom, the ice is so compressed and so old that it holds the atmosphere of a world that existed before humans had even begun to walk its surface. Inside a quiet laboratory, kept at a constant freezing temperature to protect the integrity of the archive, scientists carefully slice these cores into thin disks. When these disks are melted in a vacuum, the tiny bubbles we spoke of are finally released. They pop with a microscopic hiss, a sound that hasn't been heard for hundreds of thousands of years. This is the fossil air returning to the present, offering up its chemical secrets. It tells us exactly how much carbon was in the air when mammoths roamed the steppes, or how much volcanic ash was drifting through the sky after a distant prehistoric eruption. It is a library of the atmosphere, stored in a medium that is both incredibly fragile and remarkably enduring. As we contemplate the vast frozen silence of the poles, it's helpful to take a slow, deep breath of our own. Feel the air move in and out, a simple rhythm that has sustained life for eons. The same air we breathe today is a descendant of the air trapped in those icy bubbles. It is all part of one great circulating system, a breath that the Earth has been taking for billions of years. But the ice is not the only place where the Earth keeps its diary. While the polar regions offer a grand planetary perspective, there are other archives much closer to our own doorsteps. These records are not found in the cold, blue depths of a glacier, but in the warm, living pulse of the natural world. As we leave the white expanses of the Antarctic behind, we travel toward the temperate parts of the world, where the sunlight filters through a canopy of green and the air is thick with the scent of damp earth and growing things. Here, in the heart of the ancient forests, we find a different kind of record keeper, one that grows and breathes alongside us, marking the passage of time with every season that passes. Imagine standing before a massive fallen trunk in the heart of an ancient woodland. The air here is cool and still, filtered through layers of green leaves. If you were to look at the cross-section of that trunk, you would see a series of concentric circles, radiating outward from the center like ripples in a pond. These are the tree's rings, and each one is a chapter in a biography that the tree has been writing since it was a tiny sapling reaching for the light. The study of these rings is called dendrochronology. It is a beautiful, patient science. Each year, as the seasons turn, the tree adds a new layer of wood just beneath its bark. In the vibrant days of spring, when the soil is rich with snowmelt and the sun begins to warm the earth, the tree grows rapidly. It produces large, light-colored cells that form a wide band of early wood. As the year progresses into the heat of late summer and the cooling air of autumn, the growth slows down. The cells become smaller, their walls thicker and darker, creating a thin, dense line. This pair, the light and the dark, represents one full year of life. When a scientist looks at these rings, they aren't just counting years. They are reading the climate of the past. A wide, generous ring is a record of a prosperous year, a time when the rains were plentiful and the temperature was just right for the tree to thrive. In those years, the tree drinks deeply, expanding its reach and storing energy. But a very narrow ring, one that is barely a sliver, tells a different story. It whispers of a year of hardship, perhaps a long, punishing drought, a late spring frost that bit into the new buds, or a summer so clouded by volcanic ash that the sun could barely reach the leaves. By comparing the patterns of these rings across many different trees in a single region, researchers can create a master timeline that stretches back thousands of years. They call this cross-dating. They can match the unique fingerprint of a dry decade in a living tree with the same pattern found in a beam of wood from a centuries-old cabin, or even a piece of preserved wood found in a peat bog. It allows us to step back through time, year by year, season by season, with incredible precision. While many trees live for 100 or 200 years, providing a glimpse into our recent history, there are others that have been standing for much, much longer. These are the true elders of the archive, living bridges between the ancient world and our own. As we move away from the lush, temperate forests and climb toward the quietest, harshest parts of the high mountains, we find the oldest record keepers of all. These are trees that have seen empires rise and fall while barely adding an inch to their girth, surviving in a landscape of rock and wind where few other things can endure. High in the White Mountains of California and across the arid peaks of the Great Basin, where the air is thin and the winters are long and punishing, lives the Great Basin bristlecone pine. These trees do not look like the towering giants of a lush, emerald rainforest. Instead, they are often short, crouched, and weathered. their trunks gnarled into fantastic, spiraling shapes by centuries of wind, ice, and sand. They are the true elders of the deep archive, living witnesses to the rise and fall of entire civilizations. One of these trees, famously known as Methuselah, has been standing for over 4,800 years. Another, whose exact location is kept a closely guarded secret to ensure its continued peace, is estimated to be over 5,000 years old. To put that into perspective, when the first stones were being laid for the Great Pyramid in Egypt, these trees were already centuries old, their roots firmly anchored in the rocky soil, watching the same stars we see tonight. They were old before the concept of an alphabet was even formed. The secret to their incredible longevity lies in their patience. In a world where many living things race to grow, compete, and reproduce, the bristlecone pine chooses a path of profound stillness. It grows with an almost meditative slowness, a pace that seems more geological than biological. In some years, when the conditions are particularly harsh, the tree might only add a fraction of a millimeter to its diameter. Because of this slow, deliberate growth, the wood it produces is incredibly dense and heavy. It is saturated with a high concentration of resin, a natural, sticky preservative that acts like a chemical shield. This density makes the wood nearly invincible to the usual forces of nature. While other trees might fall and rot away within a few decades, the bristlecone pine resists the common enemies of time. Fungi cannot take hold in such compacted, resin-filled fibers. Insects find the wood far too hard and bitter to penetrate. Even after a tree finally passes away, after thousands of years of life, its trunk may remain standing for another 2 millennia, slowly being polished by the wind and airborne silt until it glows like burnished silver. It doesn't decay in the way we usually understand. It simply erodes very slowly, like a mountain. Take a slow, deep breath now. Feel the air enter your lungs and leave just as gently. Try to imagine a pace of life as slow as that of the pine. In the time it takes you to complete one single breath, the tree might have barely moved a microscopic distance in its annual growth. There is no rush in the high mountains. There is only the steady, rhythmic passage of time, recorded in the silent, dense layers of ancient wood. The tree does not worry about the passing years. It simply incorporates them into its being, layer by layer, ring by ring. The bristlecone pine teaches us that resilience often comes from being still, from enduring the cold and the wind with a quiet, unyielding strength. It reminds us that the history of our world is not just written in human books, but in the very fibers of the living things that share the planet with us. Each branch is a record of survival, a testament to the power of slow, steady endurance. As we leave these high, windy peaks and descend back toward the lowlands, we realize that the Earth's archive isn't just found in the things that reach for the sky. Sometimes, to find the oldest and most detailed records, we have to look down, past the soil, past the roots, and deep into the quiet, dark places where time seems to move at a different speed entirely. We are moving now toward the vast, silent plains at the bottom of the world's oceans, where another kind of record is being written, one grain of dust at a time, in the absolute stillness of the deep. Leaving the thin, cold air of the high mountains behind, we begin a long, slow descent. Imagine yourself drifting downward, past the forests, past the coastlines, and out over the vast blue expanse of the open ocean. As we move away from the sunlight, the water becomes a deeper and deeper shade of indigo, eventually fading into a soft, velvety blackness. Here, in the deep sea, the world is profoundly quiet. There are no storms down here, no winds to shake the branches, and no seasons to change the temperature. It is a place of eternal stillness, a massive liquid vault that covers most of our planet. If you were to shine a light into this darkness, you would see a constant, gentle rain of tiny white particles. Scientists call this marine snow. It is made of the remnants of life from the sunlit waters far above, microscopic bits of organic matter, minerals, and the tiny shells of creatures that lived and died near the surface. It takes weeks, sometimes months, for a single speck of this snow to reach the bottom, but it never stops. Day after day, year after year, for millions of years, this gentle rain has been falling, settling onto the seabed like a soft, thick blanket of dust. On the vast, flat plains of the deep ocean floor, this sediment accumulates with a patience that is almost impossible to grasp. In many parts of the deep sea, it takes about 1,000 years for just one single centimeter of sediment to build up. Think about that for a moment as you settle deeper into your pillow. A layer of dust no thicker than the width of your smallest fingernail represents 10 centuries of Earth's history. It is perhaps the slowest, most meticulous filing system in existence. Because the deep ocean is so still and the pressure is so constant, these layers remain undisturbed, piled one on top of the other in a perfect chronological sequence that stretches back for tens of millions of years. When scientists lower long, hollow tubes into this soft ooze, they can pull up a vertical record of the past, a core sample that serves as a physical timeline. The deeper they go into the mud, the further back in time they travel. A few meters of sediment might hold the entire history of human civilization, while several hundred meters can take us back to the age when the continents were still drifting into their current positions. It is a silent, heavy library of the world's secrets, preserved in the cold and the dark. But the true magic of this deep-sea archive isn't just in the mud itself. If we were to take a small sample of this soft gray sediment and place it under a powerful lens, we would discover that it is not just dirt. It is a collection of tiny, intricate treasures. We would see millions upon millions of microscopic shapes, delicate spirals, tiny spheres, and complex geometric structures. These are the discarded homes of creatures so small they are invisible to the naked eye. Yet they are some of the most important record keepers in the history of science. These tiny ancient shells are the keys to understanding the world's distant past, holding chemical signatures within their walls that tell us exactly how the Earth felt millions of years before we were here to witness it. To understand how they do this, we must look closer at their tiny, stony lives. These tiny architects of the deep are known as foraminifera, or forams for short. They are simple, single-celled beings, yet they possess a remarkable ability to build intricate stony shells from the minerals dissolved in the water around them. To the naked eye, a handful of these shells would look like nothing more than fine white sand. but under a microscope, they reveal themselves to be tiny works of art. Some are shaped like coiled snail shells, others like clusters of tiny bubbles or delicate ribbed bass. As a foraminifer grows its shell, it pulls oxygen and carbon from the seawater. But it doesn't do this randomly. The very chemistry of its shell is dictated by the temperature of the ocean at that exact moment. In warmer waters, the shell incorporates a certain balance of oxygen isotopes. In colder waters, that balance shifts. It is as if every single one of these billions of tiny creatures is born carrying a microscopic thermometer. And when its life reaches its natural end, it leaves that thermometer behind, tucked safely within the layers of the seabed. When scientists analyze these shells today, they aren't just looking at old fossils. They are reading a chemical diary of the ocean's temperature from millions of years ago. By measuring the ratio of heavy and light oxygen within the calcite, they can reconstruct the history of the Earth's climate with startling accuracy. They can tell us when the world's ice sheets were growing and when the tropical seas were expanding, all by weighing the atoms inside a shell no larger than a grain of sand. It is a profound thought that the history of our planet's climate is stored in the graveyard of the smallest lives imaginable, resting in the absolute stillness of the abyss. Take a slow, deep breath and feel the stillness of that deep-sea world. Imagine the weight of all that water above, pressing down with a gentle, constant force, keeping these records safe and undisturbed for eons. The ocean floor is a place of infinite patience, where 1,000,000 years is just a few meters of soft gray dust. But the Earth does not only keep its records in the deep blue silence of the sea. There are other archives hidden away from the sun, where the slow work of time continues in a different kind of darkness. We leave the heavy pressure of the ocean floor now, rising up through the dark water, passing through the sunlit waves, and moving inland, deep into the heart of the continents. Here, away from the tides and the currents, we find ourselves at the entrance of a quiet limestone cave. The air here is cool and still, smelling faintly of wet stone and ancient earth. As we step into the soft shadows of the cavern, the sounds of the outside world, the wind in the trees, the distant hum of life begin to fade away. In the absolute blackness of these underground chambers, a different kind of clock is ticking. It is a slow, rhythmic sound echoing softly against the damp walls. Drip, drip, drip. Here, in the shelter of the earth, the story of the world's weather is being written in stone, one drop of water at a time. The sound you hear in the absolute darkness of a cave is the sound of time itself. It is a slow, rhythmic pulse that has continued undisturbed for thousands upon thousands of years. Drip, drip, drip. Each sound represents a single moment of connection between the world above and the hidden world below. When rain falls upon the earth, it doesn't simply disappear. It begins a long, slow journey through the soil and the rock, filtered by the ground until it is pure and heavy with minerals. As this water seeps through the limestone, it dissolves small amounts of calcium carbonate, carrying the essence of the stone along with it. When that single drop of water finally reaches the ceiling of a cavern, it pauses. It clings to the cold stone, shimmering in the dark before gravity finally pulls it free. In that brief moment of hesitation, a tiny microscopic amount of mineral is left behind. This is the birth of a speleothem. From the ceiling, these minerals build downward, forming the elegant, tapering shapes we call stalactites. You can remember their name because they must hold tight to the ceiling. Where the drops land on the floor, they build upward, creating the sturdy, rounded pillars known as stalagmites. Think of these formations not just as rocks, but as a stone diary. If you were to look closely at a cross-section of a stalagmite, you would see a series of delicate, concentric rings, much like those found inside the trunk of an ancient tree. These rings are a precise record of the environment far above the cave's roof. In years of heavy, persistent rain, the layers are thick and robust, showing a world of plenty where water moved easily through the earth. In years of quiet drought, the layers are thin, almost invisible, marking a time of stillness and waiting. The beauty of this record lies in its chemistry. Just like the tiny shells on the ocean floor we discussed earlier, the calcite in these cave formations traps isotopes of oxygen and carbon. These elements act as a chemical fingerprint, revealing the temperature of the air and the types of vegetation that were growing on the surface when that specific drop of water first fell from the sky. In the cool, protected environment of the cave, away from the erosive power of wind and the sun, these records can remain perfectly preserved for hundreds of thousands, even millions of years. As you imagine the slow growth of these stones, perhaps adding only the thickness of a human hair every few years, allow your own breathing to slow down, matching the patient pace of the cave. There is no rush here. The earth is never in a hurry to tell its story. It takes its time, layering one moment upon the next, until a masterpiece of history is formed in the dark. This slow accumulation brings us to a profound realization. We are moving through a landscape of deep time, a scale of history so vast it can be difficult for the human mind to fully grasp. We often think of history in terms of centuries or perhaps a few millennia of human civilization. But the Earth's archive is much, much older. We are standing now at a specific threshold in our journey, looking back across a span of 3 million years. 3 million years is a significant milestone. It is a point where the world began to look somewhat familiar, yet remained fundamentally different from the one we inhabit today. It is a chapter in the Earth's biography that holds the secrets of how our modern climate and our modern landscapes first began to take shape. As we leave the rhythmic dripping of the cave behind and step further back into the misty reaches of the past, we begin to see the true scale of the archive we are exploring, and how much of the story is still left to be read. Take a moment now to feel the weight of your body against your bed. Let your shoulders soften and feel the steady, quiet rhythm of your breath as it flows in and out naturally and without effort. You are safe here in this quiet sanctuary of records. There is no need to hurry through these pages. We are simply observers drifting through the long, peaceful history of our home. We have been speaking of 3 million years, as if it were an eternity. And in many ways, for our human perspective, it is a span of time that stretches far beyond our ability to fully imagine. But as we step back to look at the entire library of the Earth's archive, we realize that 3 million years is just a thin sliver of a much larger volume. To truly understand the scale of the world beneath us, we must remember that the Earth itself is approximately 4.5 billion years old. Imagine, if you will, the entire history of our planet as a single massive book, thousands of pages long. In this vast biography, the 3 million years we are currently exploring would occupy less than a single page, perhaps just a few paragraphs near the very end of the final chapter. The vast majority of the Earth story was written long before the first frost of the era we are visiting tonight. It is a staggering thought, yet a comforting one. It means the Earth is a seasoned storyteller, a sturdy vessel that has carried life through countless seasons and cycles. The archive is deep, and it is reliable. This perspective of deep time allows us to settle more deeply into our rest. We are part of a narrative that is patient and enduring. The stresses of a single day or even a single year fade away when compared to the 4.5 billion years of steady geological progress. As we continue our journey, we find ourselves focusing on a specific era within that final chapter, the Pliocene epoch. 3 million years ago, the Earth was in a state of gentle transition. It was a world that would have felt strangely familiar, yet subtly different from our own. The continents had mostly moved into the positions we recognize today, but the climate was warmer, and the great ice sheets of the north had not yet fully claimed the landscape. This was a time of wandering forests and shifting currents, a period where the Earth was preparing for the more rhythmic cycles of ice and warmth that would define the ages to follow. In the Pliocene, the files of the Earth show us a planet that was beginning to settle into its modern form. As we investigate this era, we start to see how even the smallest geological changes can ripple outward, altering the breadth of the atmosphere and the temperature of the seas. We are looking back at the world as it was just before it became the world we know, reading the final entries of the ancient past. Imagine standing on a quiet coastline 3 million years ago, during the heart of the Pliocene epoch. The world would have felt remarkably familiar, yet there was a sense of profound transition in the air. The continents, those great wandering giants of stone, had almost reached the positions we see on our maps today. But there was one final monumental piece of the puzzle that was falling into place. A slow-motion event that would rewrite the climate of the entire planet. For millions of years, the Atlantic and Pacific Oceans had flowed freely into one another, exchanging their waters through a wide-deep gap between North and South America. But by 3 million years ago, the slow, relentless pressure of the Earth's tectonic plates began to push a narrow strip of land upward from the seafloor. This was the birth of the Isthmus of Panama. It was not a sudden event, but a gradual raising, a bridge of volcanic rock and sediment emerging from the blue depths, inch by inch, century by century. As this bridge of land finally closed the gap, it acted like a giant hand redirecting the flow of a stream. The currents that had once moved horizontally across the globe were suddenly blocked. The warm tropical waters of the Atlantic, no longer able to escape into the Pacific, were forced to turn northward. This redirection created what we now know as the Gulf Stream, a powerful conveyor belt of warmth that carries tropical energy toward the North Atlantic. This single geological file in the Earth's history changed everything. By bringing more moisture to the northern latitudes, the new currents provided the raw materials for the great ice sheets that would eventually define the following ages. The world began to cool, and the rhythmic cycles of the ice ages were set in motion. It is a reminder of how interconnected our world is. A small strip of land in the tropics can determine the snowfall in a forest thousands of miles away. The Earth records these massive shifts in its layers, but it also records them in much smaller, more delicate ways. While the mountains were rising and the oceans were rerouting their paths, life on the ground was responding to every change in temperature and rainfall. The forests were shifting and the flowers were blooming in new patterns. To understand exactly what the world looked like during this time of change, we have to look past the giant stones and the deep currents. We have to look at the microscopic archives that have survived the passage of 3 million years, tiny, resilient messengers that tell us the story of the ancient green world. As we move from the grand scale of shifting continents and rising mountain ranges, our focus begins to soften, narrowing down to the smallest details of the ancient world. While the Earth was busy rerouting its oceans, the life on its surface was busy living, growing, and reproducing in a rhythm that has continued for eons. To truly see the face of the Earth as it was 3 million years ago, we have to look at the records left behind by the plants, the silent, green witnesses of history. This is the realm of palynology, the study of ancient pollen and spores. It is easy to think of pollen as something fleeting, a fine yellow dust that stains the air for a few weeks in the spring and then vanishes. But in the eyes of a scientist, a single grain of pollen is one of the most durable objects on the planet. This resilience is thanks to a remarkable substance called sporopollenin. It is a complex organic polymer that coats the outer shell of every pollen grain, acting as a suit of microscopic armor. Sporopollenin is so tough that it is one of the most chemically resistant materials known to exist in the natural world. It can withstand high temperatures, strong acids, and the immense pressure of being buried deep underground for millions of years. It is, quite literally, a biological time capsule designed to protect the genetic information of a plant as it travels through the air. Take a slow, deep breath and imagine a quiet lake 3 million years ago. The water is still reflecting the prehistoric sky. Around the edges of the lake, ancient trees and wildflowers are in bloom. As the wind brushes against their branches, clouds of pollen drift across the water's surface. Eventually, these tiny grains sink, settling into the soft, dark mud at the lake's bottom. Because of their sporopollenin shells, they do not decay. Instead, they become part of the sediment, layer upon layer, year after year. They are filed away in the Earth's library, protected by the cool darkness of the mud. When we extract a core of that ancient mud today and place it under a powerful microscope, a hidden world of geometry is revealed. Each plant species has its own distinct pollen shape. Some are perfectly smooth spheres, others look like tiny ribbed footballs, and some are covered in intricate, delicate spikes. By identifying these shapes, we can reconstruct the entire ecosystem of the past with startling accuracy. We can see the exact moment when a cooling climate caused a lush forest of oaks and elms to give way to a vast open grassland. We can identify the specific flowers that bloomed in a valley that has been dry for 1,000,000 years. These tiny grains tell us the story of the ancient green world, one blossom at a time. They tell us about the humidity of the air, the length of the seasons, and the biodiversity of a world we will never walk through. They are the fingerprints of a lost wilderness preserved in the Earth's deep, quiet archives. And yet, as sturdy as pollen is, there are even more vivid ways that the Earth captures the essence of life, sometimes freezing a moment of the past in a glowing golden stone that holds the air of the ancient world itself. Imagine a sun-drenched forest from 3,000,000 years ago. The air is heavy with the scent of pine and damp earth. It is a quiet place where the only sound is the soft rustle of leaves in a warm breeze. On the trunk of a massive ancient tree, a thick, translucent liquid begins to ooze from a small break in the bark. This is resin, a sticky, protective substance that the tree produces to seal itself against the elements. It moves with an incredible patient slowness, glistening like liquid gold in the dappled sunlight. Take a slow, quiet breath. Feel the stillness of that ancient forest. As the resin flows, it acts as a gentle, inescapable trap. Perhaps a tiny gnat lands on the sticky surface, or a fragment of moss is blown into its path. The resin slowly rolls over them, enveloping them completely. Over the coming centuries, this resin will fall to the forest floor and be buried under layers of soil and sediment. Through the immense pressure of the earth and the passage of vast stretches of time, the resin undergoes a chemical change, hardening into the gemstone we know as amber. Amber is one of the most remarkable files in the deep archive because it creates a perfect golden vacuum. Inside a piece of amber, the decay that usually claims all living things is held at bay. When a scientist looks through a polished piece of this ancient resin, they aren't just seeing a shape in the stone, they are seeing the actual organism preserved in three-dimensional detail. You can see the iridescent shimmer on a beetle's wing, the delicate structure of a flower's stamen, or the tiny individual scales on a lizard's toe. It is a moment of life, suspended in a warm, honey-colored light, held exactly as it was millions of years ago. But the archive of amber holds more than just the echoes of life. Sometimes it captures the very breath of the ancient world. Within the golden depths, you might find tiny silver bubbles. These are pockets of prehistoric air, sealed away millions of years ago. By studying these bubbles, we can learn about the composition of the atmosphere during the Pliocene epoch, understanding the balance of gases that helped shape the climate of the past. These bubbles are tiny time capsules of the sky itself. Occasionally, a single perfect drop of water is trapped inside, a microscopic reservoir of ancient rain that has never touched the modern world. These golden stones allow us to look back at the physical world with startling clarity. They are the photographs of natural history, capturing the light and the life of a lost era in a way that feels intimate and immediate. Yet, as we move deeper into the layers of the earth, we discover that the planet records more than just what it can touch or trap in resin. There are archives written in a language of invisible forces, stored within the very fabric of the rocks themselves. While amber preserves the small and the delicate, the Earth's magnetic field leaves a record that spans entire continents, guided by a silent, rhythmic pulse that has been beating since the world was young. Imagine, if you can, the Earth as a giant, gentle magnet. Far beneath the crust where we rest, deep within the heart of the planet, there is a core of molten iron and nickel. This churning liquid metal creates a magnetic field that stretches out far beyond the atmosphere, wrapping the world in a silent, protective embrace. This field is invisible to our eyes, yet it is one of the most fundamental records in the deep archive. It is a pulse that has been beating for billions of years, and the Earth has found a way to write down every single beat. To find these records, we must look to the places where the Earth is still being born, the volcanic ridges and the deep rifts where molten rock rises from the interior. When a volcano erupts, it releases lava, a glowing liquid ribbon of heat. As this lava begins to flow and slowly cool, a beautiful scientific process begins. Within the liquid rock are tiny grains of minerals, most notably a mineral called magnetite. While the lava is still hot and fluid, these microscopic crystals are free to move. Because they are naturally magnetic, they act like billions of tiny invisible compass needles. They turn and align themselves perfectly with the Earth's magnetic field, pointing toward the magnetic North Pole as it exists in that very moment. As the lava continues to cool and eventually hardens into solid rock, these tiny mineral compasses are frozen in place. They are locked into the stone, forever pointing toward the north of their birth. This creates a permanent, immutable record of the Earth's magnetic orientation at a specific point in time. This is the study of paleomagnetism, the ancient magnetism of the world. By examining these frozen needles in layers of rock across the globe, scientists can read the history of the planet's magnetic life. These compasses have revealed a story of incredible movement. When researchers look at very old rocks on different continents, they find that the tiny mineral needles often point in directions that seem to make no sense. A rock in South America might have minerals pointing toward a north that is now located in the middle of the ocean. This was one of the greatest clues in understanding our world. It proved that the poles weren't the ones moving so drastically. Rather, it was the land itself. The continents are like giant, slow-moving rafts, drifting across the mantle over millions of years. The rocks carry their original magnetic signatures with them, acting as a GPS from the deep past, showing us exactly where the continents used to be and how they have rotated and traveled to reach their current positions. This record also tells us of a slow, rhythmic breath the Earth takes. Every few 100,000 years, the magnetic field weakens and then completely reverses. North becomes south, and south becomes north. These reversals are recorded in the stripes of the ocean floor, a vast stony barcode that tracks the history of the planet's shifting energy. It is a reminder that the world is never truly still. Beneath the quiet of the night, the very ground is part of a grand slow-motion dance guided by invisible forces that connect the deep core to the highest reaches of the sky. This constant rhythmic movement of the Earth is mirrored in other ways, too, not just in the shifting of the land, but in the rhythmic pull of the seas, guided by a companion that watches us from the velvet darkness. That companion, of course, is the moon. It hangs there in the quiet of the night, a silver sentinel that has watched over our world since its earliest days. Its presence is so constant that we often take it for granted, yet its influence is written into the very fabric of our planet. The moon's gravity reaches out across the void, gently pulling at the Earth's vast oceans. We see this every day as the tides, the rhythmic, predictable rise and fall of the water along our coastal lines. It is a pulse, steady and ancient, like the slow, deep breathing of the planet itself. But the tides do more than just move the water. They leave behind a physical record, a series of files stored in the very stone of the earth. These geological archives are known as rhythmites. They are a special kind of sedimentary rock, formed in places where the tide is strong and the sediment is fine, such as in ancient estuaries or shallow coastal basins. Each time the tide flows in and out, it carries a small amount of silt and sand, depositing a thin, delicate layer on the floor of the basin. When you look at a cross-section of these rocks, they appear as a series of fine alternating bands, some light, some dark, some thick, and some thin. To a geologist, these bands are not just patterns in stone, they are a calendar. Each pair of layers represents a single tidal cycle. By carefully counting and measuring these layers, scientists can reconstruct the heartbeat of the ancient world with startling precision. They can see the daily cycles of the tides from hundreds of millions of years ago. They can identify the fortnightly cycles of the spring and neap tides, and even the seasonal shifts of the years. There is a profound secret hidden within these stony rhythms. When researchers study rhythmites from the deep past, some dating back over 600 million years, they find that the patterns are different from what we see today. These ancient files reveal that the Earth was spinning much faster in the past. Hundreds of millions of years ago, a day on Earth was not 24 hours long. It was significantly shorter, and there were many more days in a single year. Perhaps most beautifully, these rocks map the history of the moon's relationship with us. The thickness and frequency of the tidal layers show that millions of years ago, the moon was much closer to the Earth than it is today. It would have appeared much larger in the night sky, its silver face dominating the darkness, and its gravitational pull would have created tides far more powerful than the ones we know. The rhythmites tell us that the moon is slowly, very slowly, drifting away from us, moving about 1.5 inches further into space every year. It is a long, slow goodbye that has been recorded in the mud and the stone for eons. As you think of that slow, steady drift, take a moment to notice your own rhythm. Feel the gentle, effortless rise and fall of your chest as you breathe. If you need to, adjust your position now. Soften your shoulders and let your head sink a little deeper into the pillow. Allow the weight of your body to be fully supported by the bed, as still and grounded as the ancient stones that hold the history of the tides. We are part of this rhythmic world, even in our rest. While the Earth's records of the moon are written in shifting sand and hardening rock, the moon itself holds a very different kind of archive. It is a place of profound stillness, where the lack of an atmosphere has created a library unlike any other in our solar system. As we look up from the rhythmic pull of our oceans toward that glowing silver sphere, we find an archive where time seems to have stopped completely. Imagine standing on the lunar surface. It is a world of absolute profound silence. There is no air to carry a sound, no breeze to brush against your skin, and no rustle of leaves. Because the moon lacks an atmosphere, it lacks the weather that constantly reshapes and erases the records of our own world. On Earth, a footprint in the sand is gone with the next rising tide. A footprint in the dirt is washed away by the first gentle rain of spring. But on the moon, the surface is a static, unchanging manuscript, where every mark is held in a state of permanent suspension. The dust that covers the moon, known as regolith, is fine and jagged, more like ground glass than the soft soil of a garden. When the astronauts of the Apollo missions stepped onto this surface, their heavy boots compressed this silver-gray dust into clear, sharp impressions. Because there is no wind to blow the dust away and no water to smooth the edges of the tread, those footprints are still there today, exactly as they were left over 50 years ago. They are as crisp as the moment the weight of the suit pressed them into the ground. Geologically, the moon is often called a dead archive. This is not meant to be a cold term, but rather a description of its stillness. It lacks the internal heat and the shifting plate tectonics that cause the Earth's crust to fold, melt, and renew itself. The moon does not recycle its history, it simply collects it. Every crater from a meteorite impact that occurred billions of years ago remains visible, layered over by newer, smaller impacts in a slow, cosmic tally. Scientists estimate that the footprints left by those first explorers could remain visible for millions of years. They will only be eroded, eventually, by the constant, microscopic rain of space dust, a process so incredibly slow that it is almost imperceptible on a human time scale. In the vacuum of the moon, time does not move in the way we understand it. It is a library where nothing is ever misplaced and no page is ever turned by the wind. It is a place where a single moment in human history has been granted a kind of immortality etched into the dust of a world that never forgets. As you think of that silver stillness, let your own body find a similar sense of quiet. Perhaps you can imagine the cool, dark vacuum of space not as a cold or frightening place, but as a vast, peaceful room where everything is at rest. There is no pressure there, only a soft, weightless suspension. Allow your breath to become as slow and steady as the passage of time on the lunar plains. You are safe, you are still, and you are resting. As we let our minds drift back from the airless, silent plains of the moon, we return to the vibrant blue and green of our own planet. Earth is a world of constant movement and cycles, but it, too, has found ways to create its own deep freeze archives. Just as the moon uses the vacuum of space to halt the passage of time, the Earth uses the power of extreme ancient gravity. In the far reaches of the north, there are vast stretches of land where the ground itself has become a vault, a giant freezer that has been locked shut for thousands of years. We are leaving the lunar dust behind to explore the realm of the permafrost, a place where the Earth keeps its most delicate biological records perfectly preserved in a layer of eternal frost. We find ourselves now in the high latitudes of the north, where the air is crisp and the horizon stretches out in a vast white expanse. Beneath the surface of this quiet tundra lies the permafrost, ground that has remained frozen for 2 or more consecutive years. In some regions, however, this ice has held its grip for tens of thousands of years, creating a natural vault of unparalleled preservation. Unlike the moon, which preserves the shape of things in its dust, the permafrost preserves the very essence of life within its icy embrace. It is the Earth's giant freezer, a silent archive where time does not just slow down, it effectively stops. Imagine the stillness of this frozen world. The ground beneath your feet is as hard as iron, locked in a state of permanent winter. Yet, within that hardness lies a softness of history. Because the organic matter trapped here is kept away from oxygen and heat, the typical processes of decay are suspended. Leaves, roots, and even the smallest microorganisms are held in a state of perfect stasis, waiting in the dark, cold silence. This is not a place of endings, but a place of incredible long-term storage. One of the most beautiful examples of this preservation involves a small, unassuming plant known as the narrow-leafed campion. Deep within the Siberian permafrost, researchers discovered a cache of seeds that had been buried by ancient squirrels over 30,000 years ago. These seeds had been tucked away in a burrow, frozen almost instantly, and kept at a constant sub-zero temperature ever since. When biologists carefully recovered these seeds and provided them with the warmth and nutrients they needed, something miraculous happened. After 30 millennia of sleep, the seeds germinated. They grew into healthy plants, eventually producing delicate white flowers, blooms that had not been seen on Earth since the Pleistocene epoch. This tells us that the permafrost is not just a graveyard of the past, but a living library of possibilities. Modern biologists study these files with a sense of profound reverence. By extracting DNA from the plants and organic materials found in these frozen layers, they can reconstruct entire ancient ecosystems. They can see which flowers bloomed during the last ice age, what the air was like, and how life adapted to a world that looked very different from our own. It is a form of biological time travel, allowed by the simple, steady presence of ice. As you listen, imagine the patient endurance of those seeds resting in the cool dark, protected from the wind and the sun. There is a great comfort in knowing that the earth holds on to its treasures so carefully. You might feel a similar sense of preservation as you settle into your blankets. Just as the permafrost cradles the history of the North, your bed cradles you, providing a safe, still space for your own body to rest and renew. Let the coolness of the air around you feel refreshing, while the warmth beneath your covers keeps you grounded and secure. These frozen records are remarkably precise, but they are not the only way the Earth tracks the passing of the seasons in its colder regions. While the permafrost stores the biology of the past, other archives are forming quietly at the bottom of ancient glacial lakes. As the ice melts and freezes in a rhythmic dance, it leaves behind a different kind of signature, one that we can count year by year with the same accuracy as the rings of a tree. We are moving from the solid, frozen ground to the still, deep waters of the North to look at the delicate layers of the world's most patient clocks. Deep beneath the surface of these glacial lakes, there is a silence, that has lasted for millennia. In this stillness, the earth is writing a diary of the seasons, recorded in delicate, alternating bands of sediment known as varves. The word varv comes from the Swedish word varv, which means a turn, a circuit, or a layer. It is a beautiful way to describe the turning of the year, captured in the quiet mud of the lake bed. Think of the lake as a giant, slow-moving hourglass. During the bright, warm months of summer, the sun melts the edges of nearby glaciers. The rushing meltwater carries sediment, bits of rock, silt, and sand into the lake. This material is relatively heavy, so it sinks through the water column quickly, forming a light-colored, coarse layer on the floor of the lake. This is the Earth's summer breath, full of movement and energy. But as the year turns and the air grows cold, the lake freezes over. A lid of ice seals the water, protecting it from the wind and the influence of the outside world. In this absolute calm, the energy of the water fades away. The finest particles, the tiny microscopic bits of clay that were suspended in the water, begin their long, slow descent. They drift down through the dark, still water like a gentle, subterranean snowfall. By the time spring returns and the ice begins to crack, these fine particles have formed a thin, dark, dense layer on top of the previous summer's silt. One light layer and one dark layer. Together, they represent exactly 1 year of the Earth's life. Just as we looked at the rings of the ancient bristlecone pine, scientists can count these varves to travel back in time with seasonal precision. Some lake beds hold tens of thousands of these couplets, stacked one on top of the other like the pages of a very old, very heavy book. Because they are so precise, varves allow us to see the exact rhythm of the ancient climate. We can see a single summer that was unusually warm by the thickness of the light silt. We can see a long, quiet winter in the depth of the dark clay. It is a calendar written in stone and dust. There is something deeply peaceful about this process. The idea of the earth taking its time, century after century, to record the passing of the sun and the arrival of the frost. It is a slow, steady accumulation, much like the way your own breath moves in and out as you drift toward sleep. As you lie there, perhaps you can visualize those layers settling in the dark. Each one is a memory of a year gone by, preserved in the cool, dark mud. It is a physical manifestation of time itself, layered, organized, and safe. But the earth does not only store its history in the ice, the trees, or the mud of a lake bed. There is another archive, one that is much closer to you. In fact, it is inside you at this very moment. We have looked at the vast external records of the world, but now we turn our attention inward to the most complex and condensed library ever created. Just as the lake bed stores the history of the seasons in its layers, every cell in your body stores the history of life itself. We are moving from the geology of the earth to the biology of the human archive, exploring a record written not in silt or ice, but in the very code of your existence. Imagine for a moment that within every single one of your cells there is a tiny coiled thread. It is so small it can only be seen with the most powerful microscopes, yet it is so long that if you were to uncoil the DNA, from just one cell, it would stretch nearly 2 meters in length. This is the human genome, the most complex and condensed library ever created. It is made of 3 billion individual letters, a sequence of 4 simple molecules that, when arranged in just the right order, provide the blueprints for everything you are. 3 billion. It is a number so vast it is hard to grasp, yet it fits comfortably inside you, repeated trillions of times over in a masterpiece of biological filing. Think of this genome as a quiet, ancient library that has been curated for millions of years. This library wasn't written all at once. It was edited, refined, and expanded over eons of time. Every ancestor you have ever had, going back to the very dawn of life, has contributed a sentence, a page, or a chapter to this book. Every cell in your body contains this full library of instructions. It is a redundant, perfect backup system. It tells your heart how to beat with a steady, calming rhythm. It tells your lungs how to draw in the cool night air. It tells your eyes how to perceive the soft fading light of the mist. But this archive carries more than just instructions for the present. It carries the echoes of the deep past. It is a biological history book, recording the challenges our ancestors faced and the traits that allowed them to thrive. Within those 3 billion letters are the files of our survival, the genetic memories of how to heal, how to grow, and how to adapt to a changing world. When scientists look at this code, they see a shared language, a universal archive that connects us to every living thing on this planet. There are segments of your DNA that are shared with the ancient trees we spoke of earlier, and with the microscopic creatures that have drifted in the oceans for millions of years. It is a reminder that you are part of an unbroken chain of life that stretches back to the very beginning. To keep this vast amount of information safe and organized, the body uses a process of incredible precision. The long strands of DNA are wound around tiny proteins, like soft silk thread on a spool, and then folded again and again into dense, beautiful structures. This ensures that the code remains protected and accessible whenever the body needs to read a specific file. As you lie here, resting, this archive is quietly at work. It is a self-sustaining record, one that doesn't require your conscious attention to function. It is a deep internal wisdom that has been passed down through the ages, a steady hand at the helm of your biology. In the stillness of the night, the work of your cells continues in a slow, rhythmic dance. The reading and writing of the code happens in the background, as natural and effortless as the tide coming in or the snow falling on a distant mountain peak. You don't have to do anything. You don't have to remember anything. The archive remembers for you. It is the most intimate record of all, the story of you, written in the language of the earth, tucked away safely within the quiet sanctuary of your own being. You are a living, breathing testament to the endurance of nature, a vessel for an ancient wisdom that is both incredibly complex and profoundly peaceful. And just as this library is held together by the delicate bonds of chemistry within your cells, it is also held in place by the greater forces of the world around us. The same laws that govern the stars and the planets also govern the quiet space where you rest now. As you feel the weight of your body sinking into the soft surface of your bed, you are experiencing the gentle, constant pull of a force that keeps everything in its rightful place, ensuring that the Earth's atmosphere and all the records it contains remains exactly where it belongs. Take a moment now to simply notice the feeling of gravity. It is a constant, quiet companion that has been with you since the very beginning of your journey. Feel the weight of your body as it presses into the bed, a soft and steady pressure that tells your muscles they no longer need to hold any tension. Your shoulders can drop a little further. Your legs can feel heavy and still. This weight is not a burden. It is a connection. It is the earth reaching out to hold you, keeping you safe and grounded while you drift toward sleep. This same force, gravity, is the silent guardian of every archive we have explored tonight. It is the reason the deep-sea sediments stay settled on the ocean floor, and the reason the ancient ice remains tucked away at the poles. But perhaps most importantly, gravity is what holds our atmosphere close to the planet's surface. Imagine the Earth spinning through the vast cold vacuum of space. Without the invisible pull of gravity, our air, the very breath of the world, would simply drift away, dissipating into the darkness. Because gravity keeps our atmosphere in place, it also preserves the files written in the wind and the rain. It keeps the oxygen bubbles trapped in the ice and the pollen grains floating in the lakes until they can settle into the earth. It creates the pressure needed for minerals to seep into bone and turn it into stone. Gravity is the binder of the Earth's great book, the glue that keeps the pages from fluttering away into the void. It is a stabilizing force, a predictable and unwavering law that ensures the story of our world remains intact, layer by layer, year by year. As you lie there, feeling that gentle pull, you might realize that you are part of a much larger equilibrium. The Earth holds onto its atmosphere, and the atmosphere holds onto the heat of the sun, creating the perfect temperate cocoon for life to flourish and for memories to be stored. It is a closed system of incredible beauty and order. Everything has its place. Everything is held. And yet, as we look up from this grounded sanctuary, we realize that the Earth is not the only archive in existence. While our world stores its history in ice, stone, and DNA, the vast space beyond our atmosphere holds a different kind of record. If you were to look out of a window and see a single point of light in the night sky, you wouldn't just be looking at a distant object. You would be looking at a file from the past, traveling across the silence of the cosmos to reach you. Just as we have learned to read the rings of a tree or the layers of a cave, we can learn to read the light that falls upon us from above. The vacuum of space, once thought to be empty, is actually filled with information, ancient signals that have been traveling for thousands or even millions of years. We are transitioning now from the archives of the earth to the archives of the heavens, where time and distance blend together into a glowing tapestry of history. The same gravity that holds you to your bed also bends the path of light across the universe, guiding these celestial records toward our eyes. As you lie there, anchored by the gentle weight of gravity, your mind might drift upward beyond the roof of your home and the soft blanket of the atmosphere. In the stillness of the night, the sky above becomes more than just a dark expanse. It is the greatest archive ever created. It is a library where the books are made of light and the shelves stretch out for trillions of miles. Every beam of starlight that touches the earth is a messenger from the past. We often think of seeing as something that happens in an instant, but in the vastness of the cosmos, light has a journey to make. It travels at a steady, unwavering speed, about 186,000 miles every single second. While that seems incredibly fast, the distances between the stars are so immense that light can take years, centuries, or even eons to reach us. When you look up at a star, you are not seeing it as it is right now. You are seeing a file of what it looked like when that light first began its journey. Consider a star or a distant galaxy located 3 million light years away. It is almost impossible to grasp such a distance, but the record it sends us is very specific. The light from that galaxy has been traveling through the silent, cold vacuum of space for 3 million years. By the time those photons reach your eyes, they are delivering a message from a different epoch of time. When that light first left its source, the Earth was in the midst of the Pliocene epoch. The world was a different place then. The continents were still shifting into their modern positions, and the ancestors of the creatures we know today were just beginning to adapt to a changing climate. That light has been moving toward us through the dark, through the rise and fall of civilizations, through the freezing and thawing of ice ages, and through the slow growth of the very forests we spoke of earlier. It is a time-traveling record, a perfect visual history preserved in the glow of the vacuum. If that star were to suddenly change or fade away tonight, we wouldn't know for another 3 million years. Its current state is a secret held by the future. Its past is the only gift it can give us now. The universe, in this way, is a vast and glowing archive. It doesn't lose information. It simply spaces it out across the dimensions of time. Every corner of the night sky is filled with these overlapping layers of history. Some stars tell us stories from 100 years ago, while others show us the universe as it looked at the very beginning of time. It is a beautiful, orderly system where nothing is ever truly forgotten. The light just keeps traveling, carrying its data through the silence, waiting for a quiet moment and a pair of eyes to finally receive it. As you breathe in and out, imagine these ancient rays of light finally completing their journey, arriving at Earth after millions of years of travel. They are soft, distant, and peaceful. They remind us that we are part of a story that is much older and much larger than we can imagine. The same physics that allow us to read the history of a tree ring allow us to read the history of the stars. The cosmos is patient, and its records are written in a language of color and heat that we are only just beginning to understand. This celestial archive is always open, even when the sun is shining or when the clouds gather. The light is always there, drifting toward us, filling the space between the worlds with the memories of suns that burned bright long before we were here to see them. It is a comforting thought that the universe preserves itself so carefully and that even the smallest point of light has a story that spans millions of years. But there's more to this light than just its age. Within those glowing beams, there is a hidden code, a way for us to know not just how old a star is, but what it is made of. Just as we can analyze the chemistry of an ancient ice core to understand the air of the past, we can analyze the chemistry of starlight to understand the very building blocks of the universe. Even from millions of light years away, the stars are telling us their secrets, one color at a time. When we look at the light from a distant sun, we aren't just seeing a simple glow. We are seeing a chemical signature, a list of ingredients written in the language of color. This is the science of spectroscopy, and it is one of the most elegant ways the universe shares its story with us. Imagine taking a single beam of that 3 million-year-old light and passing it through a glass prism. On the other side, the light spreads out into a beautiful, silent rainbow. But if you look very closely at that rainbow, you will see something unexpected. There are anti-dark lines scattered throughout the colors like thin black threads woven into a colorful fabric. These lines are the fingerprints of elements. As the light leaves the heart of a star and travels through its outer atmosphere, the atoms there, hydrogen, helium, oxygen, and even iron, absorb very specific parts of the light. They leave behind these dark gaps, these missing notes in the star's song. Because every element has its own unique pattern of lines, scientists can read that rainbow like a barcode. Without ever leaving our own planet, we can know the exact chemistry of a sun that is so far away we can barely see it with our eyes. We can see the same oxygen that we breathe today dancing in the atmosphere of a star millions of light years away. It is a quiet, profound realization that the archive of the stars is also an archive of ourselves. The heavy elements we find in these distant suns, the carbon, the nitrogen, the calcium, are the very same building blocks that make up your body. We are reading our own history in the light of the cosmos. The universe is a closed system, a great recycling project where the atoms forged in the centers of stars eventually find their way into the soil of a planet, the leaves of a tree, and the cells of a human being. There is a deep rhythmic connection between the burning archives of the sky and the quiet archives of the earth. As you listen to the sound of your own breath, let the vast, burning distances of space begin to soften and recede in your mind. The stars are beautiful, but they are far away. Feel yourself coming back to the earth, back to the cool, steady ground beneath you. While the stars record their history in beams of light that travel through the vacuum, the earth has a much slower, much denser way of keeping its records. It does not use light. It uses the weight of the land and the passage of eons. The transition from the celestial to the terrestrial is a shift from the fast to the slow. Light moves at incredible speeds, but the ground moves in centimeters over centuries. The records here are not written in rainbows, but in the very fabric of the crust. As we turn our attention away from the glowing vacuum of space and look down at the soil and the stone, we find a different kind of memory. It is a memory that is heavy and incredibly rare. We are moving from the archive of the sky to the archive of the deep earth, where the stories of life are preserved in the most patient way imaginable. In the quiet darkness of the Earth's layers, a different kind of transformation is taking place. It is a process that requires stillness, pressure, and an immense amount of time. It is here, in the silence of the sediment, that the Earth begins to create its most precious files, the ones that tell the story of life itself. These are the records that have survived the crushing weight of the mountains and the slow movement of the continents. They are the stone memories of creatures that once breathed the same air we do, preserved by a stroke of geological luck. Imagine the world as a vast, living library, where every creature that has ever lived is a story waiting to be told. Yet, for most of these stories, the pages are eventually lost to time. They return to the earth, recycled into the soil and the air, becoming part of the next generation of life. This is the natural rhythm of the world, a constant flow of energy and matter. But every so often, the earth decides to keep a page. It decides to preserve a memory in a way that defies the normal course of decay. To become a fossil is a rare and extraordinary fate. It is a journey that requires a perfect alignment of circumstances, a geological lottery where the odds are incredibly long. It is estimated that less than 1% of all living things that have ever existed leave behind a fossilized record. Most life is ephemeral, a brief flicker in the long history of the planet. But for that tiny fraction, the Earth creates a permanent file. These are the rarest documents in the deep archive, preserved against the crushing weight of time and the elements. The journey into the archive begins with a moment of profound stillness. For a fossil to form, a creature must be buried quickly, tucked away from the world of the living. Perhaps it is a leaf falling into the soft, silty bed of a quiet lake, or a shell settling into the fine mud of a river delta. This burial acts as a gentle shroud, protecting the remains from the air and the processes that usually break life down. It is a slow, heavy embrace that seals the story away, keeping it safe in the cool darkness of the sediment. As the centuries turn into millennia and the millennia into eons, the weight of the earth above increases. The layers of mud and sand press down, eventually turning into solid stone. Inside this stone cocoon, a miraculous transformation begins. This is the science of mineral replacement, a process so slow it is almost impossible to imagine. Think of tiny microscopic drops of groundwater enriched with minerals like silica or calcite, seeping through the pores of a bone or the grain of a fallen tree. Molecule by molecule, the organic material is washed away, and in its place, the minerals settle and harden. It is as if the earth is tracing over the original drawing with a permanent stone ink. The bone is no longer bone. It is a sculpture made of rock, a perfect replica of what once was. This replacement is so precise that under a microscope, we can sometimes see the individual cell walls of an ancient plant or the delicate texture of a feather. The earth has taken something fragile and made it eternal. It has turned a heartbeat into a mountain. When we find a fossil, we are holding a piece of time that has been hardened into something we can touch. It is a heavy, cool weight in the hand, a physical connection to a world that existed long before the first human looked up at the stars. It is a reminder that the earth is a patient artist working in the dark, using the slow pressure of the ground to preserve what would otherwise be lost to the wind. But the archive does not only keep records of the bodies of the past. It does not only store the shapes of bones and shells. Sometimes it preserves something even more fleeting, the moments of action, the movements, and the journeys of those who came before us. Just as a bone can turn to stone, so too can the memory of a single step taken in the mud millions of years ago. We are beginning to look not just at the remnants of the creatures themselves, but at the marks they left behind as they moved across a world we can only imagine. Think for a moment about a footprint you might leave in the sand at the edge of the sea. The next wave washes it away, returning the shore to a smooth, blank slate. But every so often, the conditions are exactly right for that single step to be preserved for millions of years. This is the world of ichnology, a word that sounds complex, but describes something very simple and beautiful: the study of traces. While a skeleton tells us about the end of a life, a trace fossil tells us about the living moment. It is the record of a journey, however short, captured in the Earth's long memory. Imagine a vast, ancient mud flat, quiet under a pale sun. A creature, perhaps one we have never seen in the flesh, walks across the damp earth. Its feet sink into the soft ground, creating a series of hollows. Before the wind or the water can erase them, the mud begins to dry and harden. Then a gentle layer of fine sand or silt washes over the area, filling the prints and sealing them like a letter in an envelope. Over eons, that mud becomes stone, and the sand inside the prints becomes a different kind of stone. When we find these trackways today, it is like opening a book to a specific page of a story that was written long before we arrived. These tracks are more than just shapes. They are biological fills filled with data. By looking at the stride length, the distance from one footprint to the next, scientists can determine the speed of the animal. We can see if it was running, perhaps in a moment of excitement or urgency, or if it was simply wandering. The depth and shape of the prints reveal the creature's weight and how it carried itself, whether it leaned forward or stood tall. It is a physical calculation of a living presence, recorded without the animal ever knowing it was leaving a permanent mark. Perhaps most movingly, these traces give us a glimpse into the social lives of the past. We might find the large, deep prints of an adult, followed closely by the smaller, lighter steps of a juvenile, telling a silent story of protection and guidance. We find vast plains covered in the footprints of hundreds of individuals, all moving in the same direction, revealing the patterns of ancient migrations. These are not just fossils. They are echoes of behavior, frozen in the Earth's patient archive. As we move from these broad landscapes of movement, our focus begins to narrow. We leave the wide open spaces of the ancient shorelines and look toward the quiet, rhythmic growth of life beneath the waves. Just as the earth records the steps of the traveler, the sea records the steady passing of time within the very bodies of its inhabitants. We are moving from the records of the journey to the records of the seasons, stored in the delicate stony rings of the creatures that call the ocean home. In the stillness of the deep, a different kind of diary is being written, one layer at a time. In the quiet, sun-dappled shallows of the tropical ocean, a different kind of archive is being written, one molecule at a time. While we have looked at the rings of trees and the layers of ice, the sea has its own method of keeping time, a science known as sclerochronology. It is a long name for a very simple and beautiful process, the way that marine creatures, like corals and mollusks, build their homes in rhythmic, predictable increments. Just as a tree adds a ring for every year of its life, these creatures add layers of calcium carbonate to their shells and skeletons, creating a biological calendar that can span centuries. Imagine the giant clam resting peacefully on a coral reef. These magnificent creatures can live for over 100 years, remaining in the same spot while the currents of the world flow around them. As the clam grows, it pulls minerals from the seawater to expand its heavy, fluted shell. Every day, every season, and every tidal cycle leaves a microscopic mark. Because the clam's growth is influenced by the temperature of the water and the amount of sunlight reaching it, its shell becomes a high-resolution record of the environment. Scientists can look at a cross-section of such a shell and see the exact conditions of the ocean from a century ago. They can tell if a summer was unusually warm or if a winter was particularly calm. For the clam, it is simply the process of building a home. For us, it is a library of the sea's history preserved in stone. Corals, too, are master record keepers. A large coral head might look like a single still object, but it is actually a colony of tiny organisms working in harmony over hundreds or even thousands of years. As they grow upward toward the light, they leave behind a dense skeletal structure. By taking a small core sample from an ancient coral, researchers can look back through time, reading the chemical signatures of the water as if they were reading the ink on a page. These sea rings tell us about the history of the Earth's climate, the changing patterns of the winds, and the health of the reefs, long before humans began keeping digital records. It is a slow, steady pulse of life captured in the quiet architecture of the deep. There is a profound comfort in knowing that the Earth has been keeping its own diary for so long, using nothing more than snow, wood, mud, and shell. These are the natural archives, the records that exist whether we are there to read them or not. They are the silent witnesses to the passage of eons. But as we continue our journey through the deep archive, our focus begins to shift. We move from the records created by the planet itself to the records created by the hands of those who live upon it. For as long as humans have looked at the stars and the seasons, we have felt the need to record our own stories, to capture our thoughts and discoveries so they might outlast our own brief lives. We began to look at the materials around us, the plants, the minerals, and even the skins of animals, and we found ways to turn them into vessels for our collective memory. We are leaving the natural world's unintentional diaries behind and stepping into the cool, shadowed halls of the human-made archive. Here, the preservation is intentional, and the materials are chosen with a deep, quiet reverence for the future. We are moving from the rhythm of the tides to the steady, careful stroke of a pen on parchment. As we step into these quiet, human-made halls, the air feels different, cooler, more still, and filled with the faint, sweet scent of aged organic materials. We are no longer looking at the growth rings of a tree or the layers of a glacier, but at the deliberate efforts of our ancestors to keep their thoughts alive. One of the most remarkable vessels for these thoughts is vellum. Unlike the paper we use today, which is often made from wood pulp and can become brittle with age, vellum is a material born of the animal kingdom. It is crafted from the skins of calves, sheep, or goats, prepared through a slow and meticulous process of cleaning, stretching, and scraping until it becomes a smooth ivory-colored surface. Vellum is a marvel of biological preservation because it is composed primarily of collagen, the same protein that gives our own skin its strength. It possesses an incredible longevity when kept in a stable environment away from the fluctuations of humidity and the harshness of direct light. Vellum does not merely survive, it thrives. It remains flexible and strong, holding its shape and its secrets for over 1,000 years. There is something deeply reassuring about the existence of an ancient manuscript. The way the page feels substantial and cool, a physical bridge across the centuries. In the silence of the archive, these pages wait, their surfaces glowing softly in the dim light, carrying the weight of history with a quiet grace. Take a slow, deep breath and imagine the steady hand of a scribe working by candlelight. The ink they used was not merely a dye, but a product of fascinating chemistry. For centuries, the standard was iron gall ink. It was created by mixing tannin, often extracted from the galls that grow on oak trees, with iron salts. When this ink touched the vellum, a chemical reaction occurred. The ink didn't just sit on the surface, it etched itself into the very fibers of the skin, becoming a permanent part of the material. This is why many ancient documents remain so legible today, even as the deep black of the fresh ink mellowed into a warm, earthy brown over the centuries. The bond between the ink and the page remained unbroken. The permanence of these records is a testament to the harmony between natural materials and human intent. The scribe knew that their words were fragile, yet they chose materials that could withstand the slow march of time. This interaction between the chemistry of the ink and the biology of the vellum created a record that is almost as enduring as the stone of a mountain or the ice of a pole. As we linger here in the quiet stacks of the human archive, we see that our desire to remember is mirrored in the very substances we use to record our history. We are not just preserving information, we are preserving a connection to the past, one careful stroke at a time. But even as we marvel at the longevity of these handwritten scrolls, we realize that the world's most vital information is not always recorded in ink. Sometimes the most important files are the ones that allow life itself to continue. Just as we tuck away our stories in cool, dark rooms, we have also learned to protect the biological blueprints of the earth. We are moving from the preservation of words to the preservation of life's potential, hidden away in a different kind of vault, deep within the frozen earth. Imagine a landscape of endless white, where the air is so cold it feels crisp and clean against your skin. This is Svalbard, a group of islands halfway between mainland Norway and the North Pole. Here, tucked away into the side of a massive sandstone mountain called Plateau Berget, is the Svalbard Global Seed Vault. It is often called the Doomsday Vault, but in the quiet of this archive, it feels much more like a sanctuary, a peaceful library for the planet's future. As you approach the entrance, you see a striking concrete wedge protruding from the snow, topped with a glimmering art installation of fiber optics and mirrors that catch the pale Arctic light. But the true archive lies far beneath the surface. To reach it, one must travel down a long, echoing tunnel burrowing deep into the heart of the permafrost. The air grows stiller and colder with every step, reaching a constant shivering temperature of minus 18 degrees Celsius. This cold is intentional. It is the breath of the archive, keeping everything within in a state of perfect icy suspension. This vault is the world's ultimate insurance policy. It is a file cabinet for the most precious data on Earth, the genetic diversity of our food crops. Inside 3 large caverns, there are rows upon rows of metal shelving, holding millions of tiny seeds. Each variety is sealed in a 3-ply foil packet, heat-sealed to keep out moisture and air. These seeds are the biological memories of 10,000 years of human agriculture. There are grains of rice from the terraced hills of Asia, hardy maize from the high Andes, and ancient varieties of wheat that have survived centuries of changing climates. The reason this archive is buried so deep in a mountain is for its incredible stability. The rock provides a natural shield against the world outside, and the permafrost acts as a fail-safe. Even if the mechanical cooling systems were to fail, the seeds would remain frozen and viable for decades, perhaps even centuries. It is a place designed to outlast us, a silent guardian of the Earth's biodiversity. Take a slow, deep breath and imagine the profound stillness inside that mountain, the weight of the rock above, the absolute darkness, and the millions of tiny lives held in a frozen embrace. Think of these seeds as tiny, dormant packages of information. They are not growing, they are waiting. In this deep, frozen sleep, their metabolic processes have slowed to a near halt. They are suspended in time, held in a state of quiet preservation until the day they might be needed to restore a lost crop or help a community recover from a forgotten harvest. This is the ultimate backup of the Earth's biological data. Just as we save our digital files to a cloud or our stories to vellum, we have realized that our very survival depends on backing up the genetic code of the plants that sustain us. It is a profound act of hope to build a vault in the middle of the frozen dark, filled with the potential for life and green fields. In the absolute silence of the mountain, surrounded by millions of sleeping seeds, there is a sense of profound security. The archive is full, the doors are sealed, and the future is tucked away in the cold, waiting for a spring that may be centuries away. As we consider these physical backups of life, we begin to realize that our methods of storage are constantly evolving. We have moved from stone to parchment, and from parchment to frozen vaults. But as we look toward the future, we are finding ways to store our information in even more fundamental ways, moving from the macro world of seeds and mountains into the microscopic world of the very code that builds us. This shift toward the microscopic is born from a quiet necessity. We often think of our digital world as permanent, a vast and shimmering cloud of information that will hover over the earth forever. But in the reality of the deep archive, digital storage is surprisingly fragile. A stone tablet can last for 5,000 years. A well-made book can last for 500. Yet, a hard drive may fail in a decade, and the digital formats we use today, the specific ways we encode our photos and our songs, may become unreadable to the computers of the future. Scientists call this the digital dark age, a silent worry that the most recorded era in human history might one day leave behind the fewest records of all. But there is a solution being written in the very language of nature. Researchers are now looking to the oldest and most efficient storage system in the known universe, DNA. While we use silicon and magnetism to store our data, nature uses the four simple bases of the DNA molecule. It is an incredibly dense medium. Theoretically, every piece of data ever created by humans, every movie, every book, every scientific paper, could be stored in a few grams of synthetic DNA, a volume no larger than a sugar cube. The process is as poetic as it is complex. Digital code, which exists as ones and zeros, is translated into the chemical sequences of DNA. These synthetic strands are then dried and stored in small, cool glass vials. Unlike a spinning hard drive or a delicate optical disc, DNA does not require electricity to maintain its integrity. If kept in a cool, dark place, much like the seed vault in Svalbard, this biological archive could remain perfectly readable for thousands, perhaps even tens of thousands of years. We are learning how to tuck our stories into the same sturdy architecture that holds the blueprint for a redwood tree or a blue whale. As you listen to this, take a slow, rhythmic breath. Feel the steady rise and fall of your chest, a motion that has its own ancient rhythm. It is comforting to think that the most advanced technology we can imagine is simply an imitation of the biological wisdom already inside you. You are, in a very real sense, a living library. Every cell in your body carries a copy of the archive that makes you who you are, a record that has been refined, protected, and passed down through an unbroken line of life reaching back to the very first sparks of existence. There is no need to worry about the preservation of the world tonight. The scientists are at work, the seeds are resting in the permafrost, and the code of life is being written into stable, silent molecules that will outlast the mountains. Your only task now is to let your own systems begin their nightly maintenance. As the weight of your body sinks a little deeper into the mattress, you can let go of the need to remember or record. Your body knows how to hold its own history. You're safe within the continuity of the archive, a single, precious volume in a library that spans the ages. Let the quiet of the room wrap around you like a soft velvet cover, protecting the pages of your thoughts as you drift closer to the stillness of sleep. We are moving now from the archives of the earth and the archives of the cell toward the most private archive of all, the one that opens only when your eyes are closed. As you drift closer to the edge of sleep, your mind begins its own quiet work in the archive of the subconscious. While your body rests, your brain remains active in a very specific, nurturing way. This is the stage of rest known as REM sleep or rapid eye movement sleep, a time when the brain's internal librarians begin their most important shift. Imagine, if you will, the events of your day as a collection of loose papers, scattered notes, and fleeting sketches. Throughout your waking hours, these are stored in a temporary area called the hippocampus, which acts as a sort of waiting room for memories. But as you sink into the depths of the night, the brain begins to sort through these files with incredible precision. During REM sleep, the brain moves these fragments of experience from the temporary waiting room into the long-term storage of the neocortex. It is a process of consolidation where the essential is kept and the unnecessary is gently let go. Scientists have observed that during this time, the brain is actually replaying the patterns of the day, but at a different rhythm, weaving them into the existing tapestry of everything you already know. It is how we learn, how we make sense of a complex conversation, or how we master a new skill. The brain is not just resting, it is organizing. It is dating the shelves of your history, making sure that when you wake, the world feels a little more coherent, a little more familiar. Think of this as a period of gentle curation. The archive of your mind is being tended to with the utmost care. There is a profound beauty in a quiet, organized mind, one where the noise of the world is filtered out, leaving behind only the meaningful echoes. As you lie here, you don't have to do any of this work yourself. Your mind knows exactly which files to keep and which to archive in the deep, silent vaults of your long-term memory. You can trust this process. You can let the thoughts of the day drift like autumn leaves, knowing they will settle exactly where they need to be. There is a sense of peace in knowing that your mind is a self-cleaning, self-organizing sanctuary. It is a space where the logic of the day gives way to the fluid, creative associations of the night. This is why dreams can feel so vivid and strange. They are often the result of the brain trying out new connections between old records, testing how a new piece of information fits into the library you have been building since the day you were born. It is a nightly rehearsal of your own identity, a way of reinforcing the story of who you are. As the rhythm of your breathing slows even further, feel the tension leaving your forehead, your jaw, and your shoulders. Your internal archive is being cared for. The lights in the corridors of your mind are dimming, leaving only the soft glow of the work being done in the background. You are becoming a quiet observer of your own restoration, drifting further away from the waking world and into the vast, gentle landscape of the subconscious. Here, there is no rush, no pressure, and no noise. There is only the steady, rhythmic pulse of a mind at rest, preparing itself for a new chapter. As we prepare to leave the archives of the mind, we look one last time at the archives of the physical world and the incredible materials that connect your very breath to the history of the cosmos. This internal archive, this library of your own life, is inextricably linked to the grander archive of the physical world. As we step back from the specific records we've explored, the ice cores, the tree rings, the deep sea sediments, we begin to see that the greatest record of all is the one you carry within you at this very moment. It is a profound scientific truth that almost every atom in your body was once forged in the furnace of a distant, ancient star. Billions of years ago, long before the Earth gathered its first layer of dust, massive stars burned with an intensity that created the carbon in your muscles, the calcium in your bones, and the iron in your blood. When those stars reached the end of their long lives, they scattered these elements across the void, seeding the clouds of gas and dust that eventually became our sun, our planet, and eventually us. This makes you a living part of the universe's archive. You are not just observing the history of the world. You are made of it. The very oxygen you are breathing right now, in this slow and steady rhythm, has cycled through the atmosphere for eons. It may have once been trapped in a bubble of Antarctic ice or exhaled by a prehistoric fern in a forest that no longer exists. You are a vessel of deep time, a beautiful collection of cosmic materials that have found a temporary precious home in the form of you. There is a deep resonant sense of safety in this vastness. The same laws of physics that govern the rotation of galaxies are the same laws that keep your heart beating and your lungs expanding. The universe is a stable, ancient system, and you belong within it. You are held by gravity, warmed by the Earth's core, and protected by the very atmosphere that stores the records we've explored tonight. The world is large, yes, but it is also consistent. It is a place of order and quiet persistence. As you settle into the final moments of our journey through the deep archive, feel the weight of your body sinking even deeper into the soft surface beneath you. The heavy lifting of the day is over. The archive is closed for the night. The stories of the earth and the stars are tucked away, safe and sound. There is nothing left for you to do, nothing left for you to learn, and nowhere else you need to be. You have traveled through millions of years and across the reaches of space, all from the comfort of your own room. You have listened to the breath of the planet and the secrets of the stones. Now, it is time for your own story to pause, to drift into the quiet chapters of rest. May your sleep be as deep as the sediment on the ocean floor and as peaceful as the silent forests of the ancient pines. May your dreams be a gentle curation of all the beauty and wonder we have touched upon tonight. You are part of a grand, quiet story that continues even while you rest. A living record of a universe that is both vast and kind. Close your eyes now. Let the world fade into a soft, warm blur and drift into the restorative darkness. Your mind is quiet. Your body is heavy. You are home. Sleep well. Sleep deeply. The archive will be here when you wake, but for now, there is only the quiet and the stars and the peace of a long, perfect rest. Good night.